Arrays and slices in Go. Question: how do you create arrays in Go? In Go, you can create arrays in several ways. You can declare an array with var, and it will be filled with 0 values. You can also initialize an array with specific values using curly braces. If you use 3 dots inside the brackets, Go will count the elements and set the array length for you. You can also create sparse arrays, where you only set values at certain positions. For example, you can set the value at index 1 to 10 and index 3 to 30, and the other positions will be 0. Go also supports multi-dimensional arrays, like grids with rows and columns.
Question: what happens when you assign one array to another in Go? In Go, arrays are value types. This means when you assign one array to another, Go creates a complete copy of the entire array. If you change the new array, the original array stays the same. This also happens when you pass an array to a function. The function gets a copy of the whole array, so any changes inside the function only affect the copy, not the original array. This is important to remember because copying large arrays can use a lot of memory and time.
Yes, you can compare arrays in Go if the elements inside them can be compared. When 2 arrays have the same length and the same values in the same order, they are equal. But you cannot compare arrays of different lengths because they are different types. For example, an array of length 3 and an array of length 4 cannot be compared. This is different from slices, which cannot be directly compared to each other. Question: when should you use arrays in Go instead of slices? You should use arrays when you have data with a fixed size that never changes. Good examples include SHA-256 hashes, which are always 32 bytes, IPv4 addresses, which are always 4 bytes, and mathematical matrices with fixed dimension. Arrays are also useful when you need to use them as keys in a map, because slices cannot be used as map keys, but arrays can. For most other situations where the size might change, slices are a better choice.
Question: what is a slice in Go? In Go, a slice is a small data structure that describes a part of an array. It contains 3 pieces of information: a pointer to where the data starts in memory, the length of the slice, which is how many elements it currently has, and the capacity, which is how many elements can fit in the underlying array before needing more space. When you have a slice variable, it doesn't store the actual data itself, but instead points to an array that holds the data. This is why slices can grow and shrink while arrays cannot.
Question: how do you create slices in Go? There are several ways to create slices in Go. You can declare a slice with var, and it will be a nil slice with no data. You can also create an empty slice with empty curly braces or by using the make function. When you use make, you can set the length and also the capacity. You can create a slice with values using curly braces, just like an array. You can also create a slice by taking a portion of an existing array using square brackets with a colon. For example, ARR 1 to 4 gives you elements from index 1 up to but not including index 4. Question: what is the difference between a nil slice and an empty slice in Go? A nil slice is declared using var and has a nil pointer inside it. An empty slice is created using empty curly braces, or make, and has a pointer that is not nil. For most operations, like getting the length, appending, or using range, they behave the same way. The important difference happens when you convert them to JSON format. A nil slice becomes the word null in JSON, while an empty slice becomes empty square brackets. If you are working with JSON, you need to choose which one you want. For most other cases, it is better to use a nil slice. Question: how does the 3-index slice work in Go? Normally, when you create a slice, its capacity goes all the way to the end of the underlying array. With the 3-index slice, you can control the capacity. You write it with 3 numbers separated by colons. The first number is where the slice starts, the second is where it ends, and the third sets the maximum capacity. This is useful when you want to prevent accidentally changing the original array. For example, if you create a slice with limited capacity and then append to it, Go will create a new array instead of using the old one, which keeps the original data safe from being overwritten. Question: how do you use the append function in Go? Append adds new elements to the end of a slice. You can append a single element, multiple elements, or another whole slice. The most important rule is that you must always capture the result of append in a variable. This is because append might need to create a new underlying array if there is not enough capacity, and it returns a new slice header. If you don't capture the return value, you will lose the new slice, and your data will not be added correctly. Question: how does a slice grow in Go when it runs out of space? When you append to a slice and it reaches its capacity, Go creates a new larger array and copies all the elements over. Before Go version 1.18, it would double the capacity until it reached 1024, then grow by about 25% after that. In Go 1.18 and later, it uses a smoother growth strategy that starts at about double for small slices and gradually changes to about 1.25 times for larger slices. This growth happens automatically, and the exact capacity may vary depending on the size of the slice. Question: why should you pre-allocate slice capacity in Go? When you know roughly how many elements a slice will hold, you should pre-allocate the capacity using make. This tells Go to reserve enough space from the beginning. If you don't pre-allocate, Go has to keep growing the slice by creating new arrays and copying data over each time. For large numbers of items, this can happen many times and slow down your program. Pre-allocating means Go only needs to create the array once, which makes your code run faster.
Question: what does the copy function do in Go? The copy function copies elements from one slice to another. It copies as many elements as it can, which is the smaller length of the two slices. So if your destination slice is smaller than the source, it only fills the destination. Copy also works when the slices overlap, which is useful for shifting elements within the same slice. The function returns the number of elements it actually copied. How do you delete elements from a slice in Go? There are different ways to delete elements from a slice. If you need to keep the order of elements, you can use append to combine the parts before and after the element you want to remove. If order doesn't matter and you want faster deletion, you can copy the last element into the position you're removing and then cut off the last element. In Go version 1.21 and later, there is a slices package with a delete function that makes this easier. You just tell it the start and end positions to remove. Question: how do you insert elements into a slice in Go? To insert an element at a specific position in a slice, you need to split the slice into two parts at the insertion point and then put them back together with the new element in the middle. In older Go versions, this requires using append with a temporary slice. Starting from Go version 1.21, there is slices package with an insert function that makes this much simpler. You just give it the slice, the index where you want to insert, and the value to insert. What is the shared backing array trap in Go slices? When you create a slice from another slice, they share the same underlying array. This means changes to one slice can affect the other slice. For example, if you take a small slice from a larger one and then append to it, you might accidentally change the original slice if the new element fits within the capacity. To avoid this problem, you can use a 3-index slice to limit the capacity. Or you can make an explicit copy of the elements so the new slice has its own separate array. This ensures changes to one slice don't affect the other. Question: how can a small slice cause memory problems in Go? When you create a small slice from a large slice, both slices share the same underlying array. This means the large array cannot be cleaned up by the garbage collector, even if you only need the small slice. For example, if you have a 1 gigabyte file and you take only the first 100 bytes as a slice, the entire 1 gigabyte stays in memory. The fix is to make a copy of just the data you need into a new slice. Then, the original large array can be freed, and your program uses much less memory. Question: what happens to pointers when you shrink a slice in Go? When you shrink a slice by taking only the first few elements, the elements you remove still exist in the underlying array. If those elements are pointers, they keep pointing to data that cannot be garbage collected. This can cause memory leaks because the data stays in memory even though you're not using it anymore. The solution is to set those removed positions to nil before you shrink the slice. This lets the garbage collector know the data can be freed. Newer versions of Go with the slices package do this automatically when you use the delete function. Question: what useful functions are in the slices package in Go? The slices package in Go version 121 and later provides many helpful functions for working with slices. You can sort slices, search for values, check if a slice contains an element, find the index of an element, remove consecutive duplicates, make copies, compare slices, reverse slices, and manage capacity. You can also delete, insert, and replace elements easily. There are functions to find the maximum and minimum values, and in Go 1.22, you can concatenate multiple slices together. This package makes common slice operations much simpler. Question: what are the different ways to loop through a slice in Go? In Go, you can loop through a slice in several ways. The most common is using range, which gives you both the index and the value. You can also use range with only the index if you don't need the values, or use range with an underscore to get only the values without the index. If you need to go through the slice backwards, you can use a traditional for loop starting from the last index down to 0. You can also reverse the slice using the slices package and then loop through it normally. Question: what is a common mistake when using range loops with slices in Go? A common mistake is forgetting that the value in a range loop is a copy of the element, not the original element itself. When you modify this copy, the original slice stays unchanged. To fix this, you should use the index to access and modify the actual element in the slice. For example, instead of trying to change the loop variable, you would write items I.something to change the element at position I. This way, you're working with the original data, not a copy. Question: what changed in Go 1.22 with range loops in closures? Before Go version 1.22, when you created functions inside a range loop that used the loop variable, all the functions would capture and use the same variable. This meant they would all see the last value from the loop. Starting with Go 1.22, each iteration of the loop creates a new variable, so each function captures its own value. This makes the behavior more intuitive and matches what most programmers expect. So now, when you create multiple functions in a loop, each one remembers the correct value from its own iteration. Question: how do you create two-dimensional slices in Go? To create a two-dimensional slice in Go, you first create a slice of slices. Then you need to loop through each row and create the inner slice. This gives you independent rows that can be accessed with two indices. There is also another approach where you allocate one big contiguous slice for all the data, and then create row slices that point into it. The second approach is better for performance because the data is stored together in memory and makes better use of the CPU cache. Both methods work, and you choose based on your needs. Question: how can you filter a slice without creating a new slice in Go? You can filter a slice without allocating new memory by reusing the same backing array. You create a new slice that starts at the beginning of the original slice with length 0. Then, as you find elements that match your condition, you append them to this new slice. This overwrites the original data, but keeps only the elements you want. This is very efficient because no new memory is needed. However, be careful because this modifies the original slice, and if your slice contains pointers, you should set the unused positions to nil to help the garbage collector. Question: how do you implement a stack using a slice in Go? To use a slice as a stack in Go, you push elements by appending them to the slice. To pop an element, you get the last element first, then shrink the slice by 1 by slicing off the last element. To peek at the top without removing it, you just access the last element directly. This is a simple and efficient way to implement stack behavior in Go using slices. Question: why is using a slice as a queue problematic in Go? While you can use a slice as a queue by appending to add items and slicing off the front to remove items, this causes a memory problem. When you remove an item from the front, the underlying array still keeps that item in memory. Over time, as you add and remove many items, the backing array grows and never shrinks, and the front positions hold onto old data that cannot be freed. For a real queue in production code, you should use a ring buffer or the container list package instead. Question: how can you split a slice into smaller batches in Go? You can split a slice into smaller chunks by using a loop that takes pieces of the slice. The function keeps taking a chunk of the specified size from the front of the slice and adding it to a result. It repeats until what's left is smaller than the chunk size, and then adds that final piece. This is useful when you need to process large amounts of data in smaller batches. The function uses the 3-index slice to limit the capacity of each chunk to exactly its size, preventing any unintended sharing between chunks. Question: how can you clear a slice in Go without creating new memory? You can clear a slice without new allocation in two main ways. First, you can write s equals s slice 0. This sets the length to 0 but keeps the same capacity, so the underlying array is reused. Second, in Go 1.21 and later, you can use the clear function. The clear function sets all elements in the slice to their 0 value, but keeps the same length and capacity. Both methods help reuse existing memory instead of creating a new slice.
Question: what is the purpose of slices.Grow in Go? Slices.Grow is used to increase the capacity of a slice at once. If you know you need to add many items to a slice, you can use slices.Grow to allocate enough space ahead of time. This helps avoid multiple small reallocations when you append items one by one, making your program faster. What does slices.Clip do in Go? Slices.Clip is used to release unused memory from a slice. If you have a slice with a large capacity but only a few items, you can use slices.Clip to cut the capacity down to match the actual length. This frees up the memory that was reserved but not being used, so your program uses less memory overall. Question: how can you convert between arrays and slices in Go? You can convert an array to a slice by using ARR:. The slice will reference the same underlying array, so no data is copied. To convert a slice to an array pointer in Go 1.17 and later, you can write *array type and pass the slice. This points to the first elements of the slice without copy. In Go 1.20 and later, you can convert a slice to an array value directly, like array type of slice. This creates a copy of the elements. If the slice has fewer elements than the array size, the program will panic at runtime. Question: what is the difference between strings, bytes, and runes in Go? In Go, a string is a sequence of bytes and usually contains UTF-8 text. When you convert a string to a byte slice, it makes a copy of the data. Converting a byte slice back to a string also makes a copy. A rune represents a Unicode character. When you convert a string to a rune slice, Go decodes the UTF-8 text and copies the characters. The length of a string is the number of bytes, but the length of a rune slice is the number of characters. When you use a range loop over a string, Go decodes it as runes and gives you the index and each character. Question: how does slices work when passed to functions in Go? When you pass a slice to a function, Go passes the slice header by value. The header contains a pointer to the backing array, the length, and the capacity. Because the pointer points to the same array, changing elements inside the function modifies the original data. However, changes to the length or capacity, like when using append, do not affect the original slice header. If you need to change the slice's length or capacity, you must return the new slice from the function. Alternatively, you can pass a pointer to the slice. Then you can modify the slice header directly inside the function. Question: what are some advanced tricks with unsafe slices in Go? In Go, the Unsafe package allows advanced tricks with slices. Starting from Go 1.17, You can use unsafe.Slice to reinterpret one slice type as another type, as long as the element sizes match. For example, you can view a slice of float64 as a slice of bytes. This does not copy the data, but changes how it is viewed. Go 1.20 added unsafe.string and unsafe.string data, which allows zero-copy conversion between strings and byte slices. However, these tricks break Go's safety rules. Strings are meant to be immutable, but these operations can change them. You should only use these techniques when performance is critical and you fully understand the risks.
Question: what is the builder pattern in Go for creating strings efficiently? The builder pattern in Go uses strings.Builder or Bytes.Buffer to build strings or byte data efficiently. Instead of joining many small strings with the plus operator, which creates many temporary copies, you write parts into a builder. The builder stores everything in a growing slice. When you are done, you call the string method to get the final result. You can also use the grow method to tell the builder how much space you need ahead of time. This reduces memory reallocations and makes your code faster. Question: what is the purpose of sync.Pool in Go, and how is it used with slices? Sync.Pool in Go is used to store temporary objects that can be reused. This helps reduce memory allocations and makes programs faster. In the example, a pool of byte slices is created. When a slice is needed, the program gets one from the pool instead of creating a new one. After using the slice, the program puts it back into the pool for others to use. Before putting it back, the slice is reset by setting its length to 0, but the underlying memory is kept for reuse. This pattern is useful for handling many temporary byte buffers in high-performance applications.
Question: what is a new feature in Go 1.22 and later for looping with the range keyword? In Go version 1.22 and later, you can use the range keyword directly with an integer. This creates a loop that runs that many times. For example, this loop will run 10 times with I taking values from 0 to 9. This is useful for simple loops where you need to repeat something a specific number of times, like filling a slice with calculated values. Tricky. Common mistakes table. Arrays versus slices comparison.